Now we're going to look at a concept known as electron configurations. And what electron configurations tell us is where electrons are with regard to their energy levels and the subshells in those energy levels. So to be able to write an electron configuration, we've got to go over some ground rules. First, each orbital in any atom can hold a maximum of 2 electrons. So that has consequences for our subshells, because subshells have a certain number of orbitals. Remember, our S subshell has 1 orbital, P subshell 3 orbitals, D subshell 5 orbitals, and F subshell 7 orbitals. So therefore, the S subshell can hold a maximum of 2 electrons, since it only has 1 orbital. The P subshell with 3 orbitals can hold a maximum of 6. The D subshell with 5 orbitals can hold a maximum of 10 electrons, and the F subshell with 7 orbitals can hold a maximum of 14 electrons. And this in turn has a consequence for each energy level or each shell. We can calculate the number of electrons an energy level can hold through the simple formula 2n squared, where n is equal to the shell level. So in the first energy level, 1 squared is 1, 2 times 1 is 2. The first energy level can hold a maximum of 2 electrons. Second energy level, 2 squared is 4. 2 times 4 is 8. Second energy level can hold a maximum of 8 electrons. Third energy level, 3 squared is 9. 2 times 9 is 18. That's the maximum number of electrons that can fit into a third energy level. Now, I use the term energy level and shell interchangeably, but let's look at how this works. We look at our first energy level, all we have is an S subshell that can hold 2 electrons, maximum number of electrons in this energy level or shell. Second shell, I have an S and a P subshell. The S can hold 2, the P can hold 6. 2 plus 6 is 8. Here's my third energy level. Remember, we calculated 18 for the third energy level. We have S, P, and D. 2 electrons, 6 electrons, and 10 electrons maximum. When we add these up together, we get 18. And then 4 times 4 is 16. 16 times 2 would be 32. 2 electrons, 6 electrons, 10 electrons, and 14 electrons maximum in each one of these subshells. The maximum number of electrons the fourth energy level or the fourth shell can hold is 32 electrons. When we write electron configurations, we place electrons in the correct energy level and the subshells, and we do that by placing electrons in the lowest energy shells and subshells first. This is what's known as the Aufbau principle. Electrons want to be as stable as they can be, so they want to be in the lowest energy orbitals that they can be first. This is an energy diagram of orbitals, subshells, and energy levels for a typical atom. And energy is going to increase as we go up. So what that means is as we go up, these energy levels are further and further away from the nucleus. The nucleus is way down below here, attracting the electrons, keeping the electrons on the atom. Okay, now let's look at how this chart is set up. What the author of this slide has done is he has made each energy level a little round circle. And I think he's done that so he can clearly give each orbital or each energy level a specific color so we can keep track of what's going on. Here's our first energy level. In the first energy level, all we have is an S subshell. And 2 electrons can fit there, and this is the color for the first energy level. The next higher energy level is the second higher energy level, and we have an S subshell and a P subshell, and the S is lower in energy than the P. The S subshell has 1 orbital, and the P subshell has 3 orbitals. Now let's look at the third energy level. The third energy level has 3 subshells, S, P, and D. The S is lower in energy than the P, which is lower in energy than the D. The S subshell has 1 orbital, the P subshell has 3 orbitals, and the D subshell has 5 orbitals. Here we have our fourth energy level, S, P, D, and F are the subshells we have. And our S subshell has 1 s orbital, P subshell 3 p orbitals, D subshell 5d orbitals, and our F subshell 7 orbitals. And then we can go on and on for our 5 and our 6. For atoms in the periodic table, we don't go beyond the F orbital, and in fact all we have in the F orbitals are F orbitals in the 4th energy level and the 5th energy level. One of the things I want to point out is that as we get higher and higher in energy level, many of these energy levels kind of become really close together. So let's look at our 6p. It's really close in energy to our 5d, which is really close in energy to our 4f. So as electrons get more and more complicated, the order in which they fill is a little more complicated as well. Here it's very clear. This is clearly lower in energy than this. 1s, 2s, 2p, 3s, 3p. But then after the 3p, then it doesn't necessarily follow that order, and it gets a little complicated, but we'll look at how we handle that and how we know what the lowest energy subshells are available to electrons. When we write electron configurations, we have got to know what the lowest energy level is, because we're going to put electrons in the lowest energy level first and go to the next energy level, next energy level. The 1s is always the lowest energy level. 2s comes next, then the 2p, then the 3s, then the 3p. But then, as I said, after the 3p, it gets a little hairy. So this diagram is very, very useful. The way that you can set it up is start out with 1s, 2s, 3s, 4s, 5s, 6s, 7s. Just write that in a column. Then where we have the p orbitals is in the 2nd energy level, right? 2p, 3p, 4p, 5p, 6p. 3d, 4d, 5d, 6d, 4f, and 5f. So from left to right, 3s, 3p, 3d, 4s, 4p, 4d, 5s, 5p, 5d, 5f, 6s, 6p, 6d. And then as we go down, we have the same subshell. So once you write out this diagram and make sure that everything is lined up correctly, you can use this to tell you which order the electrons are going to be filled. The first subshell that must be filled is your 1s, the subshell in the 1st energy level. Then what you do is you just kind of go around, and then back here, the next one is your 2s. Once that is filled, then you go on to your 2p, then go on to your 3s. We're done here, so we come back around, then your 3p, then your 4s. Then we go back around here, then we go to our 3d, our 4p, our 5s, and go back around, 4d, 5p, 6s, go back around, 4f, 5d, etc. And what we do is we fill each subshell before we go to the next. So the 1s can hold 2 electrons. We'll put 2 electrons here. And then if we have more electrons, then we go to our 2s and put 2 in here. If we still have more electrons, then we go to the 2p. P can hold 6. If I have more than 10 electrons total, then I've got to go on to the 3s. This can fit 2. And I keep on going from one subshell to the next subshell according to the direction of this diagram, filling electrons in each subshell to the maximum of their capacity before I go on to the next. So s orbitals can hold a maximum of 2, p orbitals can hold a maximum of 6, d orbitals can hold a maximum of 10, and f can hold a maximum of 14.